Okay, this is your first example on your Intro to Volumes of Revolution worksheet. I'm going to show you each of the picttures before I do the problem. So this is the region, this is the graph of 2 root x between 1 and 4, x equals 1 and x equals 4, about the x-axis. Now this is as close as I could get to y equals 0, but it's basically just to give you an idea of the picture. So this is hold on. If I revolve this around the x-axis, you can see that we have a solid disk who's in the shape of a circle, but it does have a width, and the width is where the dx comes in. And if you think about it, it's all these disks being added together to make this solid. So we need to find the volume of this solid by finding the volume of each disk and adding them all up. We use an integral to add them all up. And the height of each disk, or the width of each disk, is dx. So if you think of each disk as being a cylinder, the volume of a cylinder is pi r squared h, and in this case the h is the dx. Okay, here's example number 1. You've already seen the demonstration on Calculus in Motion to see that it creates a solid when it's revolved about the x-axis. So, like we said, each of those disks is the shape of a cylinder. It's a circle times the height of each cylinder. Well, the area of a circle is pi r squared. So the radius of each of those circles is going to be the value of the function, which is 2 root x. That's the radius. So pi r squared, pi is a constant, so we pull it out in front of the integral. We're going from 1 to 4, because that's where our region was given to us, from 1 to 4. And the radius is 2 root x, so we're going to square that times each height of each cylinder. So then you have to do some algebra and do some calculus, and hopefully that part's easy, or at least if it's not easy, hopefully it's something you can figure out. But there's my work, and there's my answer. On your paper, it's xy equals 1, so we have to decide if we're revolving around a horizontal axis or a vertical axis to decide whether we should solve for x or y. Since you're going about the x-axis, which is horizontal, we're going to have everything in terms of y. We're going to solve for y. So xy equals 1 turns into 1 over x. You're also dividing the region between x equals 1 and x equals 2, so those are these 2 points right here. And if I revolve that about the x-axis, it looks like that. And you can see how it becomes a solid that's a whole bunch of disks put together. That's what it looks like. Okay, number 2. Again, we're going about the horizontal line, the x-axis, so we're leaving everything in terms of y. So we solved this. Oh boy, hey there. We solved it so it said y equals 1 over x, because the x-axis tells us we have to solve in terms of y. Any horizontal line, you want everything in terms of y. So again, it looks like this, and it's getting revolved around the x-axis. You already saw that picture. So the radius of each circle is from 0 to the function. So it's just the value of the function. So we have pi times 1 over x squared dx, and you can integrate that. Both of these should be done without a calculator. Okay, this is number 3. We are going about the y-axis this time. So this time it's a vertical line. So we want to talk about, we have to solve in terms of x. So when you do that, you get x equals the cubed root of 2y. So that looks like that. And we also have x equals 2 as our other area. And the line y equals 0 is the x-axis. So we're going to start at the x-axis. And we're going to go up to where these two, we have to find where these two functions cross. And you'll see that they cross at x equals 4. So we're going to go from 0 to 4. And we're going to go about the line x equals 0, the y-axis. Okay, so we have the cubed root of 2y, we have x equals 2, these are the two functions, and we are going to revolve it around the x-axis. There's going to be a big old hole in the middle. So you can see that it's going to be a washer this time, not a solid. It's going to be a solid with a hole in the middle. And as you add up all those washers, you get this bowl that we need to find the volume of. Think about the y-axis. We need to put everything in terms of x. So we have to solve this equation for x, which I did right here. You get the cubed root of 2y. And then we need to integrate from y values. So where do the two lines intersect? Well, the line x equals 2 is right here, and the line cubed root of 2y is right here, and when you graph them, they cross at 2, 4. So we're going to integrate from 0 to 4 along the y-axis. Those are our y values. And this time we're going to have an opening. This is that bowl shape. And you have to think of the radius of the bowl as from here to here, from the y-axis to the outside function, and then from the y-axis to the inside function. So from the y-axis to the outside function is constant the whole way around. That radius is 2, it doesn't change. The inside function does change as it revolves around the y-axis. So that radius is the value of the function because it's being measured from the y-axis. So this we have the pi r squared for the outside one minus r squared for the inside one dy, because that's the height of each cylinder. Okay, and then you integrate that using u substitution, and hopefully you get an answer of 32 pi over 5. Okay, and then number 4, we're going about the x-axis again, and y equals 4. The x-axis, we need to see where these two things intersect right there. And we're going to revolve around the x-axis, and again, because I have it in a negative and that isn't part of the domain. There we go. So now when we revolve it, again, we're going to have washers because there's going to be a hole in the middle. So you're going to have to do the radius of the outside circle minus the radius of the inside circle. Or in other words, the area of the outside circle minus the area of the inside circle, so that you have this washer with a hole in the middle that gets added up for the total. Number 4, about the x-axis is what we've always done. It's just in terms of y, so we have it in terms of y. We have the y-axis and the horizontal line y equals 4, so they cross at 4, 4. And we're going to go about the x-axis. So we're going to have this big hole in the middle again. So the radius of the outside function is 4. So we're going 4 squared. And then subtract the radius of the inside function, which is 2 root x squared. And your answer should have been 32 pi. Hopefully this is the one I'm on. This is number 5 on your notes. Again, since we're going about the line x equals 1, which is a vertical line, we need to solve everything in terms of x. So I solved y equals x squared and got x equals the square root of y. And x equals 1. So these are here's your function and your vertical line. You're revolving this area around the line x equals 1 between the x-axis, which is y equals 0, and where they intersect, which is at the point 1, 1. So we're going from 0 to 1 along the y-axis. And you can see all these disks get bigger and bigger and bigger. So you have to think about, it's actually a disk because there is no empty space in the middle, but what are the radiuses or radii of those circles? That's what you have to think about. The radius is getting smaller as the y increases. So we're going to talk about how to figure that out. This one I gave you a picture of already. This one's different because we're not going about the x-axis or the y-axis. The reason we were able to just use the functions themselves is because the value of the function of 2 root x is being measured from the x-axis. That's like this value is whatever the y value is when x is 2 because it's being measured from the x-axis. This time the radius is going to change. It's going to be measured from this line. So again, since we're going about a vertical line, we need to put it in terms of x. So we solve this equation and get x equals root y. So this is the function x equals root y. Here's the line x equals 1. Here's y equals 0. So this is the region that we're revolving around this line. So if you think of the biggest circle on the bottom, it's going to have a radius of 1. But the next disk up is going to be a little bit smaller. That radius is going to be 1 minus whatever the value of the function is at this point. Up here, the radius is going to be much smaller. It's going to be 1 minus whatever the value is at the function here. But it's a solid object. There's no hole in the middle. So all we're doing is saying that the radius at any of these disks is 1 minus root y. And then we have to square the radius and multiply by pi, and then multiply each height of each disk, which is dy. And then again, to integrate, you're going to have to FOIL and do some calculus. But the hardest part is understanding that the radius goes from 1 to whatever 1 minus the function is.